same code, different hardware. How is that possible? When you're writing embedded software, you're constantly talking to hardware. You're flipping bits in registers, configuring pins, setting up timers, and managing all kinds of peripherals. But here's the problem. Hardware changes. The microcontroller you use today might be different tomorrow. Vendors update their chips, or you might switch to a completely new one. This is where a hardware abstraction layer, or HAL, becomes your best friend. Think of the HAL as a translator. It is a special layer of software that sits right between your main application code and the physical hardware itself. Instead of having your code directly manipulate hardware registers, it makes a simple, standardized call to a HAL function. For example, let's say you want to turn on an LED without a HAL. You'd have to find the specific GPIO register for that specific pin on that specific microcontroller and write a certain value to it. It's complicated and tied to that one chip. With a HAL, you just call a function like HAL_GPIO_write pin, telling it which pin to turn on. The HAL takes care of the rest. It knows exactly which registers to touch for the hardware you're using. So why is this so incredibly useful? The biggest reason is portability. If you decide to switch to a different microcontroller, even from a different company, a huge chunk of your application code can stay exactly the same. You just need a new HAL for the new chip. Your logic doesn't have to change, which saves an enormous amount of time and effort. Second, it makes your code so much more readable. Instead of a line of code filled with confusing hexadecimal numbers and bit shifts, you have a function that clearly states its purpose. Right to a GPIO pin. It describes what you want to do, not the nitty-gritty details of how the hardware does it. This makes it easier for you and your team to understand and maintain the code later. Third, it speeds up development. Most chip manufacturers provide a HAL for their products. These HALs are usually well-tested and come with a ton of examples, drivers for common peripherals, and detailed documentation. You don't have to reinvent the wheel every single time. But like everything in engineering, there's a trade-off. This extra layer of software, the HAL, adds a bit of overhead. The function calls take up a few extra clock cycles. The HAL itself uses up some of your microcontroller's precious flash memory and RAM. For most applications, this is totally fine. A HAL is a tool that helps you organize your access to it. So remember this simple rule. HAL saves you time. Direct register access gives you control. Knowing when to use each is what makes you a great engineer. Stay sharp, and thanks for watching.